All right, let's talk a little bit about inverse functions now. So we talked about composite functions last time, and so you'll notice that if I take a function of a function and I get back x again, and that works for all the x that's in the domain. And also, if I do it the other way, because usually we know that f of g is not equal to g of f, but that equals x also, then these things are called inverse functions. And then we usually denote it by f negative 1 of x. Now, be very, very careful. That doesn't mean 1 over f. So if I have f of x equals, let's say, x plus 2, then f inverse of x is not 1 over that. F inverse of x basically takes whatever I give it and subtracts 2. So this one adds 2, and this one undoes it. So basically, a inverse function, in a sense, undoes the function. So, a couple of things about that. The graph of an inverse function, if you graph them both, if you make them both in terms of f of x and f negative 1 of x, and you make this in terms of x, if you graph both of these functions, so if I have any function, I'm just going to make something up. So if I have some function, let's make it, let's do x cubed. Okay, so if I have x cubed, well, the inverse function would be the cube root of x, right? Because it does the opposite that one does. Well, what that does is it looks like this. And you notice something interesting, that is actually can be reflected along the line y equals x. And that's essentially what happens, is it gets reflected. It's symmetric along this line if we put both the function and its inverse on the same graph. So let's look at an example of temperature conversion. Now, I don't particularly care for this example, and because we don't usually denote things this way. I mean, most of the time we would use, instead of f and x, we'd use f equals 9/5 c plus 32, and we'd use c equals 5f minus 160 over 9. Now these two are inverse formulas because one undoes the other. So if we look at this, we would say, if I did f of g of x, then I would do f of 5x minus 160 over 9. So I'm going to plug that in for x. So 9/5 of 5x minus 160 over 9 plus 32. Well, right now I know I can see the 9 right there. So now I have 5x minus 160 over 5 plus 32 is equal to 5x. Let's distribute this denominator here. So 5x over 5 is x, minus 160 divided by 5 is 32, plus 32 equals x. So this is essentially the equivalent of converting a temperature from Celsius to Fahrenheit, and then from Fahrenheit back to Celsius. And of course, you're going to get the answer that you're going to get what you started with. And if we look at this the other way, I'm going to have g of f of x. This is going to do the same thing. This is going to be 5 of 9/5 plus 32. Oops. Minus 160 divided by 9. So let's distribute this 5. We have 5 times 9 over 5 plus 32 times 5 minus 160 divided by 9. So these 5's cancel. I have 9. Oops, I forgot my x. There's my x. I have 9x plus 160 minus 160 over 9. Now I have 9x over 9 because my 160s, that's 0. And cross off my 9s and I have x. So again, this is like converting something to Celsius temperature and then converting it back to Fahrenheit. Okay, I'm going to end up with what I started with again. So again, how I would really write these things isn't so much in terms of x. Normally, I would say, well, I can have a Fahrenheit temperature by taking, 9/5 of the Celsius temperature and adding 32. And I can find the Celsius temperature by going 5 Fahrenheit minus 160 over 9. So, because if I were to rewrite these, I wouldn't write them both with x here. I would write them as the Celsius temperature and the Fahrenheit temperature. I wouldn't use x for the Celsius and x for the Fahrenheit temperature. That's as confusing as heck. So normally I would really write inverses like this. But of course, they wouldn't graph correctly if I did that. But if I put them both in terms of x and change that variable, then it does. So normally we don't. But let's look at more about inverses. So are these two inverses? So are these functions inverses? That's the question. So let's decide. We need, let's call this one f of x. Let's call this one g of x. And let's see if one of these undoes the other one. So this function takes x, multiplies by 3, and then subtracts 8. This function adds 8 and then divides by 3. So is this function the exact opposite of this one? Well, to figure that out, we find f of g of x. So 3 x plus 8 over 3 minus 8. So these 3's cancel. I end up with x plus 8 minus 8. And I end up with x. So let's go the other direction and make sure this is still giving me back what I started with again. So now I'm going to take this x and put in this. So I have 3x minus 8 plus 8 divided by 3. So negative 8 plus 8 is 3x over 3, which is x. So the answer is yes. These are inverses. So they undo each other. They do the opposite thing in the opposite order. That makes them inverses. So let's talk about a one-to-one function and what a one-to-one function is. A function is one-to-one if each output of the function corresponds to exactly one input. Now, a function is where each input has exactly one output, but a one-to-one function has the opposite going too. And in other words, the inverse is a function too. So let's look at two examples, and you can tell me whether these are one-to-one functions. Let's look at x cubed. If I put an answer in for x cubed, or if I tried to find the inverse of x cubed, so y equals x cubed, what is the opposite? Taking the cube root, right? So the inverse would take the cube root. Is this a function also? So if I put an answer in there, do I know what I'm going to get? Yes. Because I can put, if I put negative 8, it'll give me negative 2. But if I put positive 8, it'll give me positive 2. However, when I try to do x squared, if I try to undo x squared, it's a square root. But wait a minute, it's positive or negative. So it has an or situation. So this inverse is not a function, which means that x squared is not a one-to-one function. And here's another example. We can determine, so looking at this, undoing something like this, this takes x, then squares it, then multiplies by 5. So the opposite would take x, divide by 5, and then take the square root. But wait a minute, we don't know if it's the positive or the negative square root. So we don't know what that does. This one cubes a number and then subtracts 3. So the opposite, or subtracts 2, sorry. So the opposite will add 2 and then take the cube root. There's no or situation here. There is an or situation here. So this one is not one-to-one. This one is one-to-one. And that brings me to the horizontal line test. So the horizontal line test, you can tell if a function is one-to-one. So parabolas are not one-to-one functions because I can draw a horizontal line and I go through 2 points. Whereas when I did x cubed, I can't do that anywhere. So this one is a one-to-one function. And that's what the horizontal line test is. Pretty cool. So let's look at these and let's do the horizontal line test for these. So if I were to go graph, and we'll take get last times off here. So if I were going to go over here and graph 5x squared, and let's just zoom that to standard, it fails the horizontal line test. Because if I try to draw a line, I go through 2 points right there. So this fails the horizontal line test. So therefore, it's not one-to-one. So this one fails. We already knew that. Let's test this one. X. Oops. I want to go right there. Change that to a 3 minus 2. All right, let's look at what that looks like. Okay. So that's what x cubed minus 2 is. And again, no matter what, if I put a line, I can't find a place that I can cross more than one. Yes, it gets very close right here, but it still does not cross more than once. So this one passes the horizontal line test. So therefore, this one is one-to-one. Okay. So let's talk about some inverses. So let's determine if f of x equals x to the 5th minus 1, if that has an inverse function. Well, it appears to f x to the 5th. Let's look at this. Let's change this to x to the 5th minus 1. Let's see what that looks like. Okay, yeah, it does look like that. Now I could zoom into that and you can see how that is not exactly that kind of line. So this passes the horizontal line test. And I can show you a little bit. If I zoom into where it crosses right there, doesn't quite get exactly horizontal. If I were to look at this and move this with my trace, you can see how it moves up just a little bit. It looks negative 0.999989, but it does move. So this passes. So A, yes, it passes the horizontal line test. Now B, we have to verify that this is the inverse function. So our original function takes something to the fifth power, then subtracts 1. So remember, our inverse function will do the exact opposite in the opposite order. So it should first add 1, then take the fifth root. So let's make sure that's correct. So if we have f of g of x, f of the fifth root of x plus 1, so instead of x, we're going to put this guy in here. The fifth root of x plus 1 to the fifth power minus 1. So anything to the fifth power, any fifth root of something to the fifth power will be x plus 1 minus 1 equals x. And g of f of x, we can do it this way also. So that means g of x to the fifth minus 1, the fifth root of x to the fifth minus 1 plus 1 is the fifth root of x to the fifth, which is x. So we verified that that was an inverse. Now C, find the domain and range of each function. What is the domain and range of each function? When we looked at our graph, and let's zoom back out. If I looked at the graph of this, can you see anything that x can't be of either function? And let's look at this real quick. Let's graph the other one. To graph a fifth root, one easy way to do it is you can actually go to math, and right here you have root and you have an x, so you do 5. And I can say the fifth root of, there we go, x plus 1. So let's look at this. And interestingly enough, that looks like it can be anything either. And yes, even eventually, x could be any number. I mean, if you have a really large x, it's going to take a really large, well, to get to a really large y, you're going to have a really, really, really big x. But you can eventually get to everything. So the domain and range of both are all real numbers or negative infinity to infinity. Okay, next page. So let's talk about finding the inverse. Now I've kind of talked about an easy way to think about it in that it does the opposite of what the function does in reverse order. However, we can also look at it this way. That we rewrite the equation replacing f of x with y instead. Then we interchange the x and y. I really don't like this part because normally if you're dealing in the real world with real variables, you wouldn't switch x and y. Or W and L or whatever you have. W and L, it might be the width and the length. You're not going to take x units and P is price and switch that and then make P units and X price. You're not going to do that because of the way that you're writing things. But sometimes we have to do it, especially if we want to graph them together in order to see that phenomenon. So we solve the new equation for y. And if it cannot be solved uniquely, then the function has no inverse function. Okay. And then we replace y with f negative 1 of x. Okay, so let's do this. So let's find the inverse function of this. So I'm going to call this y equals 4x minus 3 over 5. Now I'm going to switch x and y. Okay, I don't just flip this over. And I'm going to say this one more time, just because I want to. There. You don't do that. I could have just put one line through it, I suppose. So now I'm just going to solve for y. So first step, put 5x on either side. 4y minus 3. Add 3 to both sides. 5x plus 3 is 4y. Dividing everything by 4. Y equals 5x plus 3 over 4. There, that's it. Next one. Let's graph these two on their same axes. Remember, this was, well, we got to write this as f inverse is 5x plus 3 over 4. So it's 5x plus 3 over 4. That's my inverse. So let's look at those. So remember, I have to put that numerator in parentheses. 4x minus 3 div 5 over 5x plus 3 div 4. Oops, didn't delete the rest of that. Oops, shouldn't have done it that way. 5x plus 3 div 4. So let's graph these and see what they look like. And I kind of envy those of you who have colors, because you guys can see them a lot better than I can. And so you can see, I'm not sure if you can, let's make that's zoomed to standard. It's kind of hard to tell. However, if I were to put the line y equals x on here, which I'll go ahead and do. Oops, I want that one. I want x3. I wonder if I can make this. Trying to make that one different. There we go. I'm going to make that a heavier line so you can see it a little better. But now you can see this is the line y equals x, and you can see how these are symmetric around the line y equals x. Oops, now my craziness is, okay. I'm going to keep that like that anyway. All right, so let's look at this. So let's look at another one. So this one is x cubed minus 2 and the cube root of x plus 2. And you can see, if I put the line y equals x right here, you can see how, boom, boom, we can see how this is symmetric right about the line y equals x. So let's do an example. And you'll see what happens and the reason that I don't always switch my variables. A business property is purchased with the promise to pay off an $80,000 business loan plus $22,000 interest on this loan by making 60 monthly payments of $1,700. The amount of money, A, remaining to be paid on the loan plus interest is given by the function A equals 102,000 minus 1,700 t, where t is the monthly payments remaining. Find the inverse of this function. Now I can find the inverse of this function, but I'm not going to switch what t and a are because I want them to stay t equal time and amount to be a. So I'm just going to rewrite this equation in as t equals in terms of a. So I want to isolate t. So a minus 102 equals negative 1,700 t. So all I did was subtract 102 to both sides. Now I'm going to divide negative 1,700. And I get t equals a minus 102 divided by negative 1700. And if you don't like that negative, you can multiply the top and the bottom by -1. And that switches around, which is kind of a cool thing. It switches around the subtraction on the top. It makes the bottom positive. So that's a little cleaner. And use the inverse to determine how many monthly payments remain if 37,400 remains to be paid. So let's find out. So here, T equals 102,000 minus 37,400 over 1,700. So let's see what we get. 102 minus 37400 divided by 17 is 38 payments. Okay, so T is the number of monthly payments remaining. So 38 payments left. Still owe money. Okay. So now I want to talk a little bit about inverses on limited domains. Now sometimes we limit the domain of our original function f of x. So if f of x equals x squared, now we know this does not have an inverse. An inverse function on x in all real numbers on negative infinity to infinity, because we end up with f inverse having to be plus or minus the square root of x. Well, we can't write that way. So, but what we can do is, what if we restrict our x, our original x, to be x greater than or equal to 0. If that is the case, then we can say that the inverse function equals the square root of x. Because then we're just doing the opposite. And we're not worrying about anything. So now the range, so the domain of the original x is positive, the range of the inverse of x is now positive, x greater than or equal to 0. And for that matter, the range of this one is also greater than or equal to 0. And the domain of this one is also, so the range domain is x has to be greater than, so everything has to be greater than or equal to 0, which we do a lot when we're talking about applied problems. We don't have to worry so much about our x being less than 0, especially if we're talking about the number of units sold or the price of something. We don't have to worry about that too much. So we'll talk a little bit more about it in this in class and do some more examples, but I think you guys are going to get it.